Part B asks to write as a product of linear factors. All right, so we're fine except for this term x squared plus 1. Now, we know that that can't be factored. If it was written as x squared minus 1, I could have factored it because this is a difference of squares. I could have taken the square root of the first and the square root of the last, plus or minus, and I could have factored. But with x squared plus 1, I can't do that. However, I can write that as x squared minus negative 1. Now that's the same with a little bit of a change. Now this I can factor because I can take the square root of x squared and I get x and x. And I can take the square root of negative 1, which is just I. And I put plus and minus in the middle. And there we go. I've just factored it. So f of x can be written as x minus 4, x plus 2, x plus 3, x plus I, x minus I. And for part C, it says list all the zeros of kx. Well, the zeros are x equals 4, negative 2, negative 3, and plus or minus I. All right, for the next part, we're given zeros, and we have to go backwards and write the polynomial function. All right, so I have a 0 of negative 1, of 2, 2 minus I, but whenever I have a complex 0, remember imaginary numbers come in pairs. So if I'm given 2 minus I, the complex conjugate 2 plus I is also a solution. So that gives me a total of 4 zeros. So it has to be a polynomial of degree 4. All right. So f of x is, remember each 0 gives us its own factor. So the first factor is x plus 1, x minus 2, and now x minus 2 minus I, x minus 2 plus I. If I distribute the negative, then what do I get here? X minus 2 plus I, x minus 2 minus I. Now, let me just go and FOIL this part, and I'm going to get x squared minus x minus 2. Now here are my brackets. Originally I had my parentheses around the 2 and the I, but I can put them around the x and the 2. So now what I have is a difference of 2 squares. I have x plus 2 plus I, x plus 2 minus I. That means once I copy this over, what I really have is the x minus 2 squared, and then I have the I squared with a minus in the middle. So here I have x squared minus 4x plus 4 minus I squared. This is minus negative 1. So that's a plus 5. So let me just write that as a plus 5. And now I distribute and I multiply and I simplify. And finally, my f of x will be x to the 4 minus 5x cubed plus 7x squared plus 3x minus 10. And there we have it. All right. Well, what if I'm given 1 0 and I need to find the rest? Well, let's see. I have that 2 plus 5i is a 0 of this function p of x. And I need to find the other ones. Well, I know that if 2 plus 5i is a 0, then so is 2 minus 5i. Since the degree is 4, then I know I need to find 2 additional ones for a total of 4. All right, so what we're going to do is use one of the zeros in a synthetic substitution to get a depressed polynomial and go from there. Okay, so here I have 2 plus 5i. I'm going to spread this out, so I need a little bit more space. And here I need 1, negative 6, 35, negative 50, negative 58. 1 comes down, and I have 2 plus 5i. When I add this way, negative 6 plus 2 is negative 4 plus 5i. Now, let me go on my scratch paper here. I need to multiply 2 plus 5i times negative 4 plus 5i. So when I distribute, I get negative 8 plus 10i minus 20i plus 25i squared. Negative 8 minus 10i minus 25. So negative 8 minus 25 is negative 33 minus 10i. So here I get negative 33 minus 10i. When I add, I get 2 minus 10i. And now I'm going to multiply 2 plus 5i, 2 minus 10i. I do the same thing, and I get 54 minus 10i. I add this way, and I get 4 minus 10i. I multiply, I do the similar thing that I did before, and magically I get 58 with a 0 here. Okay, so what do I have now? I have a function. This is the depressed polynomial with these coefficients. Well, that doesn't really give me anything. So what I'm going to do now is I'm going to do another synthetic division, this time using the second 0. And remember now, my new polynomial has coefficients that are the ones in the bottom line here. 1, negative 4 plus 5i, 2 minus 10i, 4 minus 10i. So I'm going to do synthetic division with this now. 1 comes down. 2 minus 5i times 1 is 2 minus 5i. You add, you magically get negative 2. You multiply, we get negative 4 plus 10i. We add, we get negative 2. You multiply, you get negative 4 plus 10i. You add, you get 0. There you have it. So now the depressed polynomial from here, remember we started with x to the 4. We got x cubed, and now we have x squared. So x squared minus 2x minus 2. Now, can we find the zeros of this? Sure we can. We can't factor this, but we have to do the quadratic formula. So it's negative b plus or minus the square root of b squared minus 4 times negative 2 all over 2. This is the square root of 12 over 2. 2 plus or minus 2 root 3 over 2. 1 plus or minus root 3. So there you have it. Those are the other two zeros. So all of the zeros then would be 2 minus 5i, 1 plus or minus 3i, and so on. Now it also says to write the linear factorization of this. So let's go ahead and do that. I need to carve out some space here. The linear factorization is going to be this. So this is p of x equals. Now, x minus 2 plus 5i, x minus 2 minus 5i, x minus 1 plus root 3, and x minus 1 minus root 3. You can leave it like that, or you can simplify further to p of x equal to x minus 2 minus 5i, x minus 2 plus 5i, x minus 1 minus root 3, x minus 1 plus root 3. All right, next one. So it says to write this as the product of linear and irreducible quadratic factors. Fine. Let's do p over q. P is plus or minus 1 plus or minus 3. Q is plus or minus 1. When we do p over q, we get plus or minus 1, plus or minus 3, and now you go to do your synthetic division, and you quickly realize, well, after doing all four, you realize that, you know what? Let's see, what do we have here? You have 1, 0, 0, 3 for x to the power of 3, 2, 1, 0. You try every single one, and guess what? None of them work. Why? That just means there are no rational zeros. Well, let me write that here. Now, how are we going to factor this then? Well, let's take x cubed minus 3 and set it equal to 0. All right? X cubed would equal to 3. And now I can take the cube root of both sides. So x would be cube root of 3. So now the cube root of 3 is a solution. Why don't I do synthetic substitution with the cube root of 3? 1 comes down. This is cube root of 3. That is cube root of 3. Now I multiply cube root of 3, cube root of 3. That gives me cube root of 9. Here I have cube root of 9. Now I multiply cube root of 9, cube root of 3. That gives me cube root of 27, which is 3. Oh, and this is negative 3. So here I get 3, and I get a 0 here. Okay, so what are my factors? Well, from here, x minus cube root of 3. Why not? And from here, x cubed becomes x squared plus cube root of 3x plus cube root of 9. All right, and there we have it. So that is section 2.4. Thank you.